So can someone admit Priyanka? Do you guys have that access?
No.
No? Okay. Yeah, I just admitted it. Yeah, I'm sharing my PowerPoint, okay? Uh, yeah. So cool. Yeah. So I'm running this slideshow first. Okay. Basically, solid principles, okay, are need to be followed in application development, whatever application it is. Okay. These are the best practices you can say, or methods you can say, right, during our application development. Though it is a simple monolithic application that you are implementing or a microservices application, any kind of application it is, not only particular to Java or not only particular to a domain, okay? Anywhere in your application development, if you follow them right, it will make your application more user friendly in terms of maintenance, okay? In terms of maintenance, reusability, all you will be achieving it. If you guys already know about the Spring IOC, how it is working with runtime polymorphism, almost you covered all the solid principles, but you don't know. For the namesake, you don't know I followed solid or not, but you did followed. If you already know about Spring Core concept, there we are following it. Okay, there we are following it. Okay, that I will conclude end of the session. Okay, I will conclude end of the session. But I am not using Spring framework, sir. But do I need to follow solid principles in my application development means? Yes, if you follow, then your application will be stronger enough for the future modifications and maintenance. Okay, this is the best way that you can code. Okay, along with all other design patterns which you uh, come across in your application development. Okay, basically what s- S stands for is single responsibility principle, SRP, single responsibility. In solid, S stands for single responsibility. What it is saying while writing your class, okay, or consider if you are doing a complete module implementation. So I'm implementing a module, sir, or I'm implementing a microservice, sir, or I'm implementing a single class, sir. So do I need to apply this single responsibility principle everywhere means yes. You should apply this for class or your module or your service. In all the levels, you can apply this, which means whatever number of classes you are going to write for your application, they should have a single responsibility only. For example, I have application for employee payroll. Okay, employee payroll. In that employee payroll system, I have for some employee classes. Okay, I have some payroll classes as well. So do I need to club all this logic together? Means no, you should write them in a separate class. Employee functionality under employee class, payroll functionality into payroll class. So that what I can achieve is in case in future, okay, if I need to modify payroll information only, I should go to this payroll class and I can able to modify it. I can able to modify payroll information only. If I need to add some employee parameters, I can edit only employee class and modify it. In simple words, you need to decide while writing your classes, right? After your functional documentation, okay, you will design, right? From business document, you will write a functional documentation. There you will identify how many classes I may required. Okay, so during that documentation also you keep this single responsibility in mind and segregate your classes based on independent functionalities. Employee functionalities I have, so keep it into employee class. Payroll functionalities I have, keep it into payroll class. Don't club, right? Functionalities which are not related to that particular entity. This you can apply in class level. Simple. Okay. It is simple. I am an employee. What are my responsibilities? As an employee, I should have my roles, employee roles or employee operations. That what I need to do, I should keep it into employee class. If it is related to payroll, calculating, payroll information, calculating, how many days worked, what is the salary for that so and so days, what is the attendance, that all you may consider into payroll. Okay. So try to make it small and independent always your classes. Okay. So you can apply for any domain. Okay. This you can apply for any domain in classes level. Okay. In classes level it is clear. What about in modules level or in monolithic application? Okay. I'm designing a monolithic applications or a e-commerce application. Monolithic stands for a single deployable unit. Okay. Means all team members will work on a same project. We will have only one repository. From that repository we create, right? We create our own branches. From that branches we do pull code and there we start working it, right? So I have a monolithic application which is single deployable unit. There also should I apply this single responsibility? Means yes, in, in modules level, module responsibility. So I identified there are 10 modules. Okay. So without identifying the modules, if you put all the modules code together, then your code will be clumsy and it is not easy to maintain your monolithic application. I have a e-commerce system. There I have modules like customer module where actually customer will search for the product and buy the product. I have inventory module where actually inventory people will create products into my application. I have a delivery module where delivery people will track the products. So like this, I have multiple modules. Do I need to club all these modules into same packages or within the same application? Do I need to club all delivery code into customer code into inventory? Can I jumble like that? Means no, you should not do that. Instead, right? Create modules separately. Maybe create a separate module project and there you implement it. Later you include that module into your application so that it is easy to maintain in future. If there are changes to customer module, directly you can visit customer module and there you can apply changes. So it will be easy to maintain if you segregate your modules in such a way. So that is also you can call it as a single responsibility. And separation of concerns while writing your code. Let's say I'm implementing a web application, sir, so which is monolithic, a web application. I'm implementing a customer module. I have requirement to take a customer registration. Yes, I have requirement to take customer registration. Just a minute, guys. I'll use just a minute. Actually, this we covered already in the previous session, just revising it. And the other patterns are also simple to understand. Uh, just a minute, I'm connecting a tool. Okay. So separation of concerns. Considered, I have a MVC application, employee registration. Okay, talking about the separation of concerns. Okay, I have a MVC application. Okay, I have simple customer registration forms are there. I have, customer input. Customer input I'm getting from a form, a name, email, address details. So I want to register that into database. So in that scenario, right? As you need to keep this MVC in mind, okay? Separation of your concerns. So to read your form data, which is view, right? The view data, to read view data, you need to have a controller. So which helps you to read data. Once you read data, if you have any business calculations, okay, or any business related code, you can keep it into business class. And finally, to store data into database, you can have a DO class, which helps you to store data into database. So this is how you can separate your concerns, okay? Separate your concerns, which means you know the based on the functionality, right? Based on the use case, okay? For each use case you can have one controller, one business and one DO class, okay? So that easily you can able to achieve the inversion of controlling here. Other design patterns also, right? Easily we can apply here. Not only single responsibility, when you divide your application like a MVC, you can able to achieve all the patterns easily. And decoupling, okay? So we should not have tightly coupled relationship, okay? Between our objects, between our classes, we should not have tightly coupled relationship. So I have controller class, I want to talk with business class, but you should not have tightly coupled relationship, okay? In general, in Java, what we do create object directly, right? We do create objects directly here. In class C, we create B class object directly. In class B, we create D class object directly. But that is a bad practice, okay? That is what we discuss in Spring also, right? In first sessions itself, we used to say, right? Don't inject directly your objects. Instead of, we ask to use interface dependency injection to achieve loosely coupling, okay? So your classes should be loosely coupled, okay? Decoupled or whatever you say, okay? And avoid god objects, right? We talked about it. Avoid god object, which means what? Don't put all the code into one single class. Don't put all this code into one single class. We call it as a god class, means which is not easily modifiable, which is not easily maintainable, okay? If you keep everything together into a single class, that is bad way of coding. That is bad way of coding. So you should avoid creating god objects also. So what I will achieve end of the day? Okay, sir, classes clearly I have created. Classes I created separately based on each use case, right? Single responsible classes I created, single responsible modules I created. During even my use case implementation, I have separated my classes based on the functionality, and I maintain the decoupled relationship between them, and I don't have any god classes. So what end of the day you achieved? Easy maintainable, your application is easy scalable, right? In case any problems in your application, you can understand where the problem is and why these performance issues I am getting, so that easily you can address that. Easily you can address that and you can maintain it. I have problems, right? I have problems in the application, okay? I have problems in the application, okay, somewhere in one module. So easily I can visit that module and easily I can able to maintain it. And I have some problems in the business class, I can go and modify business only. I have problems in DAO, I can go to DAO and where I can modify it, okay? So this is how you should able to create your monolithic application, just by following the standards. Even you can apply that in microservices level also, okay? So as I have a monolithic application where everything I need to implement together, sir, but in microservices I will be having lot of microservices. How I can decide how to create each microservice? Same, right? E-commerce application I have, sir, there I have modules. I have a customers module, I have customer module, inventory module, delivery module, sir. So how I can implement microservices? Same modules you can convert into microservices. Same modules you can convert into microservice. Customer module as a microservice, inventory module as a microservice, delivery module as a microservice. For that, what all you need to understand first? Clear responsibility, which means you should identify in your requirements. When a customer asks you create a e-commerce application, okay, you need to know how many modules he want, how many modules he want, and does they have each module having a clear responsibility, or he is having some crash functional customer always interacting with inventory always interacting with delivery. If you have such a relationship, you can't make it as a microservice. But any application, right, we can create it as a microservice by reducing that responsibilities. Okay. So each module, okay, each module you can create it as a microservice so that you can achieve clear responsibility. Autonomous, each microservice should be independently manageable, independently deployable, right? So it should be autonomous. It should have its own, database, data isolation also. You need not to share customer data with inventory or inventory data with customer, vice versa. Need not to share. In microservices, we maintain separate database, right? So data isolation also you would able to achieve it. Decentralization, you need not to keep everything into one single server or in one single location. You can decide customers. I have from north region many customers or south regions many customers. So I can decide in which region I can able to, I should put my customer application. Inventory people are from north region, so I can keep it into north region servers. Anywhere I can deploy my application. I can go to cloud, I can get the space in whichever region I want, I can keep it. I can have multiple servers, so in each server I can deploy my microservice so that I can decentralize my deployment. Not only deployment, your, of course, when we call decentralized, yes, your functionality is decentralized. They are not together, right? So we have different servers so that we have we can easily able to maintain it, or easily we can able to scale it up, right? I have customer module getting so many requests to the customer module. I want to scale it up. Yes, you can apply scaling for that customer module only. Easy scaling. And boundary context, each one should have its own boundary context. Okay. Boundary context, how we can assume it is, if you visit amazon.com, right, they will be there, we will have www.amazon.com for the customers. Okay. www.amazon.com for customers. So we use this domain only for customers. So customer module code will link up with this domain. What about inventory? For inventory there will be a different domain. For delivery people there will be a different domain. So while creating your application, you need to keep this context also in the mind from the business, right? Customer management teams may be different, inventory management teams may be different, delivery people may be different. So they will have their own domains. You really need not to have same domain or same context. Okay. So based on the boundaries, if it is falling under customer, you need to keep it under customer microservices only. If it is belongs to inventory microservices only. Okay. So like that you can decide the boundaries of a microservice. And communication and collaboration, right? Communication and collaboration. You need to provide APIs for communicating one service with another microservice. Let's say inventory data, inventory data I want to fetch in the delivery, so that once delivery is done, I will update inventory information. So if you want to get that, you need not to directly interact. I mean, you need not to connect with inventory database. So between delivery and inventory, you can have a API. You can have a API. Just a minute, guys. So here you can have a API. Via API, you can have access. So when you decentralize it, obviously you need to provide API. Microservices always will provide API via Swagger or any open source, right? API documentation, we provide a documentation so that others can understand easily and they can able to make request to your microservice. Okay. So what I am trying to convey here is this single responsibility you can apply everywhere, classes level, in modules level, in monolithic, in MVC level. Okay. And in microservices, service level also you can apply. So you will get a lot of benefits out of it. Okay. So in simple words, single responsibility will make your application clean and green. Okay. It will make your application clean. So easy to maintain, easy to scale. Okay, and data isolation also we are achieving it in terms of microservices. In monolithic that is not possible because all the modules we have in the same application only. So everybody, I mean other module people also can fetch data from your tables. Okay, you should not say this is belongs to me, don't fetch. We can't put that restrictions. But in microservices, data isolation, I have my own database, so others will not connect with it. I don't give permissions to them. Okay, so data isolation also is possible here. Okay, that is good, sir. So I understand single responsibility so that I can make a clean and green application to achieve the scalability, maintainability and all. What is the next principle? So the next principle is the next principle is open close principle. Open close. What it is? What is open? What is close? Why you should follow this? Okay, so if you read this, according to this principle, software entities, okay, according to this principle, here it is saying software entities. According to this principle, software entities, which means your classes or modules or functions or microservices you can add. Okay, anything, classes or modules or functions, microservices should be open for extension but closed for modification. Getting this? So your classes, okay, whatever classes you are writing, or your modules, or your microservices should be open for extension, but closed for modification. Okay. So for example, I have implemented a class. I have implemented a class. Okay. Consider I have implemented a class transaction fund transfer. Okay. Let's say I'm working on one payment application. Okay, consider I have a phone pay application, phone pay or Google Pay. Okay, so I have a GPay application or phone pay application or RuPay, whatever it is. Okay, lot of UPIs we have, right? So I have one UPI application. Okay, Google Pay. I have implemented fund transfer. Okay, I have implemented fund transfer API. Okay, it can be a class or it can be a function, okay, or a microservice altogether. What it is saying, fund to transfer function you implemented, that is good. Okay, so consider one of you implemented this fund transfer function. Abhishek implemented fund transfer function, and this fund transfer function given to all other clients also. Google Pay integrated with everywhere. For every e-commerce application and all retail stores, they are using Google API. Internally, they are using fund transfers of Google API. Okay. So in this fund transfer method, something a signature you added in fund transfer method during Abhishek implementation, he added he added some parameters. He added some input parameters here, input 1, input 2, some variables and some output return value, everything he added. Okay, consider like a simple method. Okay, I created one method, sir. Abhishek is saying I created one fund transfer method, sir. It is taking customer account number and how much fund need to do transferred. After that, I am returning remaining balance, sir. That is what functionality I implemented. Now his functionality, okay, whatever fund transfer functionality he implemented in his class, that should be open for extension. You should not restrict other developers to don't uh, don't reuse my functionality. Already you implemented it. In future, if there are any changes required, we should allow others to and modify extend your functionality and achieve new functionality out of it. Okay, let me take a whiteboard here. Okay, clearly I'll explain. Okay, so whiteboard is visible, right?
Yes.
Okay, cool. Yeah, guys, don't hover your mouses here. I didn't stop any controls. Okay. Yeah. So I have implemented, right? So Abhishek is saying I have implemented API, sir. I have implemented here the GPay API. I have implemented functionality here. I have implemented a function, fund transfer with some input, account number and amount. I have implemented it, which is working perfectly fine. Okay. So during your implementation, don't put any restrictions. Okay. Try to make it your application almost public, your function public. You know, right, in Java, what we need to do? Our method or function should be public so that others can able to access it. And whichever class you have written, try to make it extensible. Sometimes, we people may put some conditions, right? Restrictions, final. If we put final to a class, what will happen? Final classes are not extensible. They are final itself. They are final itself. We can't extend them and we can't modify them. Don't do that. If you do that, your class is not extensible. As it is, people should use. Otherwise, your functionality need to throw it in a bin. But we should not, we can't throw it also. Okay. Why? Because already this functionality given to so many e-commerce vendors, let's say Amazon integrated, Flipkart integrated your functionality, same functionality which Abhishek implemented, Flipkart implemented, and other e-commerce or other products in the market, retail, some retail stores, right? Some payment gateways are being used or already using your functionality which you implemented. If you don't allow others to modify, it is okay. Still your customers can able to use your functionality. Still your customers who are already consuming your API, they can able to use it. Okay. So why I'm allowing or asking to make it public in future, we found this functionality inside this functionality not following any RBI guidelines. RBI guidelines are not following. I need to modify it. Right? Paytm didn't follow any RBI guidelines, so that's why they closed Paytm. Maybe business or we don't know where they missed it. So somehow I missed the RBI guidelines, so I want to modify it. Okay, I want to modify it. So your functionality should allow you to modify. Okay, so open for extension. Your functionality should open for extension. Okay, first thing is it should open for extension. So you should able to extend it. Okay, new person Abhishek implemented it. Abhishek implemented it. Now, right, Shashank want to modify it, so he can pitch in and he can create new functionality, public fund transfer. He can create fund transfer with the same account number and amount, and he can put the new code here. So what he need to achieve with the new functionality, new guidelines he need to follow, or new calculations he need to follow, and he need to implement it. Okay, your code is extensible for others. Okay, you allowed others to modify or extend it. Okay, not modify, you allowed others to extend it. Okay, so by extending this, okay, by extending this functionality, Seshank should not modify your signature or your code. He should extend it, and as it is same input parameters, output parameters he need to use. Okay, to add the new functionality. So he added new functionality here. So via this new functionality, right, he can also provide API. So while providing API, he should not to disturb existing API, because Amazon, Flipkart, other retail stores or payment gateways, they all are not ready to migrate as of now. I open a window, I asked them new functionality also ready. Maybe it is available for next 6 months. So within that 6 months, you migrate it to new API. So maybe few payment gateways are migrated. Still, old people or still my old customers are not modified it. So as soon as I implement a new functionality, I should not discard the old functionality. I should not discard, or I should not disturb the old functionality, because if you discard your old functionality, old customers will get the issues. Okay. So in nowadays we are creating everything as a API and we are sharing it to lot of customers without informing them. If you modify your functionality, their functionalities will break. Their functionalities will break. So try to make it, try to not modify it, keep your old functionality as it is and inform them, okay, I implemented a new functionality also, move towards a new functionality. So they will take some time and modify it. During new functionality
Hello, sir.
implementation also.
Hello, sir.
Yeah.
Sir, here, sorry. In place of, let's suppose we modify the functionality, but for the others who are not, who are using the old one, we can give a separate image for them, and for that new customer, we can provide a new one.
Yes.
That is that is also possible with the Kubernetes.
No, don't imagine from the, yeah, maybe Kubernetes also providing that. That's a good. What I am saying is, don't discard your functionalities first. Okay. People who are not expert in microservices, what they used to do, they will modify their APIs without any hesitation, because they come from monolithic background. They don't keep all this in mind, they modify it. But that is a bad practice. When they modify it, they will see lot of problems from the existing customers. Okay. So we should not modify existing functionality in first hand. Okay. You should not modify existing functionality or existing signatures. As it is, old functionality should function first, and you can add a new functionality also. For a new functionality adding, your code is open. As per open and close principle, your code is open. Whatever functionality Abhishek implemented, which is open. Open for what? Open for extension. And while Shashank implementing it, he should not modify it. He should not modify existing functionality. As he allowed his functionality, I'll modify his functionality also. No, don't touch his code. Open for extension, close for modifications. Close for modifications. You should not modify his code. You should not modify his code. That's a common practice that you should follow. And as well as you need to follow the same signature. Keep client in the mind. Okay. Earlier Abhishek functionality accepting one account number here and amount here. Now I will add some new input parameters. I will add some new input parameters. Along with this two, I will add two more parameters. Don't do that. Don't do that. Okay. Try to follow same signature. Okay. As much as possible, try to follow the same signature. In case, sir, I have extra parameters for the new functionality. Okay. For the new functionality, how I can achieve that here, sir? Okay. So if you have such a use case, okay, while creating the first API itself, okay, this is bad way of coding, right? Creating multiple input parameters is a bad way. Instead of multiple parameters, you keep everything into a single POSO class, account number and all, keep it into a single POSO class, keep it into a single POSO class, so that inside POSO class you can do modifications. Coming to this input will accept only one single POSO, which means I'll take one input object instead of independent parameters. So in future, if I want to modify, maybe one extra JSON parameter I will add, one extra JSON parameter I will add, so that in future when I provide new functionality, right, customers will not surprise. They will feel that, okay, this is also looking like a old input object. One extra parameter he added, let me add that. Okay, end of the day, what I wanted to achieve here, I want to make it simple for my customers. I want to make it simple for my customers without doing much modifications. Without doing much modifications. Okay, let me go to the slide. Okay, so whatever code I implement, a class or a module or a microservice, try to make it open for extension. Don't restrict that, hey, you others should not extend my functionality in future. Obviously, they will extend. Right. Client paid for us to implement it today. Tomorrow he want to modify it. Let's allow to modify. because business strategies will change, right? Every day business strategies will change. So definitely business people will come up with the new ideas to change the existing functionalities. So in that scenario, you should not say, hey, I implemented functionality or a microservice or a class in such a way others can't modify. They need to again rewrite every logic. That is not possible. You should allow to extend the existing functionality. Okay, you should keep that also in mind. So your code should be open for extension and closed for modifications. Why it is saying don't modify it? Okay, I allowed you to modify, I allowed you to extend it by taking that advantage. If you modify everything, existing APIs also, don't go to existing code and modify it. What it is saying clearly, you don't modify existing class. You don't to modify existing class. Instead of modifying existing class, extend that class and modify the functionality. Extend that class and modify the functionality. Simple inheritance principle we have. If you want to apply in class level, if you want to apply this in the class level, right, we have inheritance. We can have, right, the functionality in parent class, whichever I have, I can extend that functionality into child class using simple inheritance. Extends keyword in class level. Okay, using extends keyword, I can get parent functionality into child class. I can able to add new functionality there. Simple inheritance principle. But you should able to apply the same motivation in module level. You should able to apply it in microservices level also. Okay, in module level, how I can do that, sir? Means I have one module. If you want rewrite that module, keep old module as it is, and whichever classes you want to modify, extend that class and modify. Okay, let me show you. Open close. Okay, open for extension, closed for modifications. In monolithic, as I said, right, using extends keyword, you may extend old functionality and you can modify it. Right, open. My classes are open for extension and don't modify the my existing functionality. Closed for modification. In microservices, how I can achieve it? In microservices, sir, in class level it is okay, but I have microservice. I implemented already a microservice, like as I give an example, right? I have a microservice. Okay, so how I can restrict it? How I can restrict it from modification? Okay, so already I have a functionality API I have shared with all the customers. Okay, RBI created one API. RBI, Reserve Bank of India, will monitor all the banks. So RBI API every bank is using. ICICI Bank is using. HDFC is using. All other banks are using here. Axis, Citibank, etc. Okay, Kotak Mahindra. All the banks are connecting with the RBI API. One microservice Sailesh implemented here. In RBI, consider he is working. He implemented daily. Okay, so daily transactions. So all transactions, every bank need to report to RBI. Okay, every bank need to report to RBI. So you are working in RBI. You created a API microservice to take daily transactions. You created a microservice. Okay, tomorrow RBI given new guidelines. Okay, RBI given new guidelines to take daily transactions. So it is asked you to, add new API. What you need to do, daily transactions, first version I have here. I have given some URL here. I have URL here. First version URL I have here. Okay, something HTTP slash transactions I have. Let's keep it V1. V1 should continue. Okay. Whenever you give first version, try to give versioning also here. V1 version I have. Tomorrow, if I create a new microservice for daily transactions, I'll keep new microservice here. Transactions slash V2. One more version I will put here. So that is what they are mentioning here, versioning. So daily transactions, one more API, one more microservice I want to create it. But try to keep the same URL with the new versions so that it will be easy to customers to add the new functionality. So RBI will say what once your development is done, Sailesh implemented a new API and he said to RBI team, I implemented new daily, you know, funds information that I need to collect from banks, sir. I implemented it. I did not modify the existing API, still that is there. Okay, and new version also implemented. Then immediately RBI will say to all the banks what they will notify all the banks. They will publish saying that from next month onwards you need to use a new API. One API document RBI will provide, one new API, new version we created, use that new version. So these people will plan accordingly, right? They also need to plan and develop, and they need to deploy their applications, right? It is not easy immediately. If RBI say for the next day itself they can't modify it, they need to give some time also. So RBI will give time here, next 3 months or next 6 months, to these banks migrate to the new API. Till then they should able to continue with the old version also. That is how versioning will help a lot in open source principle. Okay, so open for extension means create a new APIs. That means you should not close old APIs. If you close, immediately it will affect on all your clients. So all the banks will shut down, right? If you understand this functionality in the banking, right? So I created a new API, and put a new version of it. Okay, old version also customers should able to use. We need to inform them. If you want to discard the old functionality, you need to inform them, right? We have old functionality also still in live that will be there for next 6 months or 1 year. Later we discard it. You need to keep post them alerts, continuous alerts. You need to post them that modify, we will be closing in next 1 year, 1 year, 1 year, so that they will be notified very ahead before, and they can move their functionality to new version. Okay, via APIs you can provide it, or event driven architecture also. Maybe you can use some message queues. Okay, message queues, there you can post your data. Via that new events also they should able to consume it. Okay, I don't want to go in depth into it, but this is also one more way to achieve it. Service composition means that is what. So while you are creating microservices, you can have old service and as well as you can have new service also. Okay, you can have old service and you can have new service also. That's how you can implement your microservices. Okay, yeah. So I think you understand what is open and close principle. I think you understand clearly what is open and close principle. Okay. We'll go with the next principle. So far we discussed about single responsibility, open and close also. The next one is Lisco, Lisco substitution principle, LSP. Lisco substitution principle. If you already done with your Spring Core module, right? You can relate all this, with your Spring IOC. Okay, so these other, Lixo substitution or the next two principles, right? Inversion, interface aggregation or dependency inversion are easy to understand. Okay, yeah. In Lixo substitution principle, stating that objects of superclass should be replaceable with objects of its subclass without affecting the correctness of the program. For example, we have a superclass bird and subclass duck and sparrow. Any method expecting a bird object should work correctly with the duck object also and a sparrow. Easily I should able to substitute. In this principle itself, he is saying substitution should be easy. Substitution should be easy. Okay. Today I am working with 5 employees. One employee moved on. He moved on and I need to able to hire a new employee. I should able to substitute the old employee. That's how I can easily able to manage my team. So everywhere substitution is important. This, as per this principle, if you see automobile, right, substitution they are providing. I have a car is having tires. After 30,000, 40,000 kilometers, they ripped off. I need to install new wheels, new tires, obviously. So I should able to substitute it. Getting right? So I should able to remove the old tires and I should able to install the new tires, whichever brand I like it. My wheel or my car rim should not say, hey, don't remove the old wheel. Will it say? No. It will allow you to remove old tires and it will allow you to install new tires. Same way your application also, right? Same way your application also, today working with one class, okay? So tomorrow I feel that that class is vulnerable or that class is old and not performing well. I wanted to move towards new class, new functionality or new feature. So your application should not restrict you to do that. For this in Java, right, 20 years before itself, they given this runtime polymorphism concept. Overriding concept they given. So that easily you will achieve it. Okay, lick show substitution in Java, how we can achieve. Okay, I was giving simple example of car, right? I was giving simple example of car. I have a car here. Okay, I have a car here. Okay, car or jeep. Okay, which is having wheels. Okay, it will allow you to substitute. It will lick show substitution principle, lick show substitution, LST or what it is, LSP, lick show substitution principle. As per LSP principle, I don't move your cursor. Okay, as per LSP principle, we are allowed to change tire, right? Tires we are allowed to change. Same way your application also. I have returned a class, I have a class, or I have an application. My application classes should allow me to change. So here I have a registration functionality, simple registration functionality. Okay. So I have a controller. You should follow MVC to achieve Lixo substitution. Controller, business, and the DO classes I have here. They are connecting with the database. My front end connecting with controller, controller connecting with business, business connecting with DAO. How I can achieve here the same loosely coupled type. So consider, if you consider each layer as a tire, okay, each layer as a tire, controller as a tire, business as a tire, DAO as a tire. I want to, let's say one tire got damaged. Okay, I have a Jeep here, one tire got damaged, front wheel, front right side wheel got damaged. I can easily able to replace it. I can put a stepney wheel or I can install new tire. Same way, I see I'm using old functionality here, JDBC code, that is not giving me so many advantages, or functionality running very slow and it is producing exceptions also. We realized it, right? When many people interacted with JDBC plain code, it is producing exceptions. So I see that that functionality is not enough for me. I want to migrate my code to new DAO. I want to create one more new DAO functionality, with JDBC template or advanced connection pooling concepts. So whenever you want to discard or whenever you want to change from old to new DAO, your business class will cry, because if you directly use a D class object here, if you directly use a D class object here, whenever you discard your D class here, it will cry. It will say, no, 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 I don't allow you. Or it will say, modify my class also, edit my class and modify wherever I have D references. If you try to put such dependencies, what you will see, as and when you modify or when you remove d class, right, it will show errors here. It will immediately produce error here. If there is any error in B class, immediately it will produce errors in C class, which means across your application it will show all unnecessary errors. How I can avoid that? That is what Lickshow substitution principle is saying. Instead of directly creating objects of D class, you need to use interfaces. First thing, you need to have an interface, DAO interface here. From DAO interface, okay, you need to implement this D class or new D class. And here in this business class, you need to use DAO interface instead of DAO class. So into DAO interface, you can able to pass old DAO class or new DAO class. Without any errors, it will work. That is what we do in inversion of controlling by using auto wiring, right? If you see in auto wiring, right? In auto wiring, what we do? In auto wiring, what we do when we have classes here into controller class or service class or DAO classes. Before implementing these classes, for every class we put one interface, DAO interface, service interface. Okay. From service interface, we implement service class. From DAO interface, implement DAO class. And we do auto wiring here. We use @auto wired of DAO interface. Into interface, any implementation we can inject. Today I'm injecting D. Tomorrow I can inject a new DAO. And I have Hibernate DAO new DAO implementation, anything I can inject here. It will allow me to inject anything. It will allow me to inject anything because in service class, I don't have directly service dependent DAO dependency. Instead, I have DAO interface dependency. Okay. Let me draw it clearly. This is not big enough. What I will do, I'll do it in paint. Okay. Let me share with the paint. Okay. Okay. After this principle, I'll give break. Then we will rejoin after 5 minutes break. Okay. I'll share this paint window, show all windows. Okay. Hope this paint is visible, right? Yeah. So here, while implementing it, right, customer registration. Okay. Customer registration form. I'm implementing customer registration. So you will have front end here. That is fine. Now coming to backend implementation, while implementing controller, especially not for controllers, for service layer and DAO layer, it is important, right? While implementing service or DAO classes, you always create one interface first. I have a DAO, customer DAO interface. First to create a customer DAO interface, in interface what we will have? Only signatures. So implement it in your DAO class. Okay, I'm using JDBC. So create JDBC DAO. And I have a service class here. So service also need to service interface. Service also need to implement from service interface. So during injecting this object, right, DAO object, don't use directly auto wired of JDBC DAO. We should not put directly this reference. Instead of what we need to do in Java, it is possible to put into interface, right? I can have customer DAO interface. Into that interface, I can inject this implementation. So in future, if I discard it, it will not throw any error. If I implement a new hibernated DAO here, so this DAO also is allowed to inject here. Same way here while auto wiring your services, keep service interface so that you can inject this old service. If you implement any new service in future, that new service also you can able to inject it. It is possible because of Java runtime polymorphism. In Java, it is possible that I can have, let's say, if I have a parent class and a child class, I can create object in many ways. How? C equal to new C, child object directly I can create, or I can put parent reference equal to child object. This will allow you to create in both the ways, right? It is allowing me to create object by using parent reference and direct child reference also. This is the best way to use. This is best way to use. Here parent can be a interface or it can be a class also. Okay. So don't worry, if I have a interface here, can I put interface reference into interface? Can I pass child object? Means of course you can do that. It is very much possible. So by using this principle only, they are saying while implementing Spring-based application, do auto-wire of interfaces instead of direct implementations. So this is what Liksho substitution principle. What it is saying, if you want to substitute some functionality, easily you should be able to substitute it. That is what Liksho substitution principle is saying. Substitution should be easy. I have a tire damaged for my car. I should be able to substitute with a new tire. My SIM got damaged in my phone. I should be able to substitute my SIM with a new SIM card. Right? Even for human also, when some organ is damaged, we able to substitute it. Right? Why can't we apply that for classes? We should able to apply it. Okay? We should able to apply it. Anything substitution is possible. So if you create your application in such a way, right, it will be more advantage. It will be giving more advantage for the future modifications. You might have heard last year or last before year, I think 2 years back, log4j vulnerability issue we got. Log4j vulnerability issues across all the applications. Excuse me. That fine day, all customers, everybody asked us to change some configurations or remove that API and add new API and immediately do the deployment. So they announced it as it has vulnerability. Immediately you need to modify it. Otherwise, hackers will hack your application easily in such a way that API was designed. So when you find that your implementations are having such code, you should be able to discard immediately and you should be able to add new functionality. It should allow you. If you already followed Liksho substitution principle, old classes immediately you can remove, delete them, and you can add new functionalities without any hesitation. So your application still function it. Okay. This beauty we discuss more in Spring, right? In Spring, always we talk about it, inversion of controlling. By using dependency injection concept, we achieve it using IOC containers. They help us a lot to achieve it, right? Using dependency injection auto wiring concepts, we achieve it by using our IOC container. So Liksho substitution principle also one of the important principle that you should follow. Okay. So yeah, that you can apply for microservices and monolithic also. So in monolithic, what it is saying, use inheritance. Of course, using inheritance, we extend the functionalities or we implement the functionalities of superclass and use polymorphism. Yes, we can use polymorphism so that we can able to pass at runtime. We can able to pass at runtime using runtime polymorphism only, right? Into parent object, we can able to pass child classes. That is what runtime polymorphism is. Overriding methods. While overriding methods, don't again, right? One principle should not conflict the other principle. Okay. Already we have discussed other principles. Okay. What are they? Single responsibility and open close. In open close, what we discussed, we should open for extension and don't modify it. Don't modify it. In Liksho substitution principle, substitution implementations, it is asking us to provide. That means you should not modify the old behavior. Okay. So that is what saying behavior preservation. Don't change the existing behaviors. Okay. Keep it in mind while following Liksho substitution. Don't forget to open and close also. Okay. Don't forget open and close. So if you follow everything together, it will be easy, right? It will be easy. Hmm. Okay. So the next principle in microservices also, service interfaces, API contracts, versioning and capabilities, dependency injection and composition. Same thing, same story. Okay. Service interfaces. While creating microservices, don't modify any API contracts. API contracts are very important. Okay. In microservices discussions, right? I'll give more insight about it. I have front end team. They are talking with the backend microservices teams via API contracts only. They need not to talk each other. We need to provide contracts in such a way. So what it is saying, while providing substitution, don't forget API contracts, existing APIs. As I was saying, versioning, right? You should follow existing contracts as it is. In case if you have drastic changes, you should inform them very ahead before, so that easily they can able to modify their existing functionalities. Okay. And dependency injection and composition, same thing, whatever we have in Spring Boot or microservices. And interface aggregation. Okay, shall we take break? We'll take 5 minutes break and we'll close these two principles. Okay, so understanding these two principles are simple. Okay, interface aggregation and dependency inversion. Okay, and I'll conclude the complete solid. Okay, I'll conclude the complete solid. Okay, yeah. So take 5 minutes break. We'll come back. Do you guys able to see PPT?
No, on the
Whiteboard.
paint is shared.
Oh,
You can
got
see
it.
the whiteboard.
Okay, anyway, what I was referring is now.
Yes,
Yes.
yes.
Yeah, so hope you understand, right? Substitutional principle, how it will work. You need to follow inheritance principle, extension, and polymorphism, right? Polymorphism means creating. Inheritance means by using extends keyword, we can extend the old functionality, right? Or we can extend the interfaces. Extends or implement. Both will both will provide you inheritance possibilities. Polymorphism, keeping child objects into parent references. Method overrides, you can do overridings, right? So parent, today I have a new child class and new child class also can have the same functionalities, while overriding methods don't change the signatures. Behavior present preservation, same thing they are saying, don't change any behavior. So while substitutioning, don't change it, follow open close to modifications. You are overriding it, it's okay, but don't modify it. Don't modify the existing functionalities. Okay, you can follow same thing in microservices also while creating your microservices. Okay, don't forget old contracts, keep old APIs as it is. Via versioning we achieve it. Okay, via versioning we can achieve it. Service interfaces, in the sense, maybe you can use gateway kind of things here, so that though you modify or you change the old functionalities also, it will not affect your clients. Via gateway we give access. So that is what it is saying, service interfaces. I have a number of services, or I have payment service here. Tomorrow I modified the payment service port or server plus port I have here. I modified it, I deployed into new server and new port. Still okay, your customer need not to bother about it. As he is talking via gateway, new services also will be registered into gateway. They don't see any problems. They don't see any problems. So that's how you need to provide gateways here. Gateways will ensure easily you can substitute new APIs. So it is referring gateway. It is referring gateway. API contracts. APIs you should not modify by using versioning v1, v2, v3. Create any number of versions. Give back, I mean, old version compatibility also. Dependency injection and composition. Of course, you know about it, right? Dependency injection, how we can achieve it. In Spring, we have this concept of dependency injection. Okay. Now, interface aggregation, and the other principle is dependency inversion. Okay. After 5 minutes break, we will discuss it. Okay. After 5 minutes break, we will discuss about it. Okay. Take break. Okay. And we'll continue it. I'll pause this recording for time being. Okay. And we will continue it. Yeah. So far we discussed single responsibility. Okay. S for single responsibility, O for open and close, L for Likshow substitutional principle, and I and D are pending. Okay. So I stands for interface segregation. Interface segregation principle. What it is clearly saying is, while you are, we learned Likshow substitutional. In Likshow substitution, we understand that we need to create a interface and implement so that we can achieve runtime polymorphism. Easily, I can modify old classes with new classes. That is what we learned here, right? So during that phase, what it is saying, okay, you are doing that, right? While doing that, don't create a big interfaces. It is saying that to achieve that, you will follow this interface implementation model to achieve Likshow substitutional. While creating your interfaces, don't make your interfaces big. Don't interfaces too big with too many methods. Okay, to achieve this, all customer functionality, payroll functionality, XYZ, everything I'll put it in one interface and I'll try to implement it. That is a bad way. Okay, that is a bad way. Instead of that, for each functionality, again, right, interface segregation, if you try to adopt or if you try to apply single responsibility principle, single responsibility for your interfaces also, it will create the beauty. Okay, I need not to explain much. Single responsibility apply for interfaces also. That is what interface aggregation means. Let's say, for example, a machine, they are comparing this with a machine, Xerox machine. When you visit a Xerox machine, sometimes that machines will have print functionality, scan functionality, fax functionality also. Okay. If you create an interface that have print, scan, fax, all the machines really need to implement a print, scan, fax, not required. I want only Xerox, print is sufficient. I want only scanning, scan is sufficient. I want to only fax machine. So fax interface itself is enough. If when you can segregate it, we can get the different implementations also, so that it is really not required. When print is only sufficient for me, print functionality only I will implement. I need not to unnecessarily worry about scan and fax. Getting right? If I have a interface in such a way, okay, let me use paint. So while creating interfaces, if I can do, yeah. So a machine I have, printing machine, okay, a machine I have, a Xerox shop machine, okay, Xerox, sorry, Xerox machine I have, okay, there I have all the functionalities, all the features in it, okay. So I want to achieve this Likshow substitution principle, so I want to create interface first. So in the Xerox machine interface, I have a print method with a signature, scan method with signature, okay, and fax method with signature. If I put everything in a single interface, if I put it in a single interface, this is a bad interface. Okay, this is interface only, but not a good interface. You can call this interface as a God interface, like God classes. Okay, avoid this God interfaces. So what God interfaces will ask you? It will ask you to implement everything. If you try to implement this interface, if you try to implement a class Xerox machine implementation, you need to compulsory implement all the methods: print, implementation, scan, implementation, fax, implementation. Everything you need to implement. But I don't want all these in my mission. I just want a printing functionality is sufficient, scanning functionality is sufficient. Or for now, I want print only. Later, I'll think about scanning. Or later, I'll think about fax. I'll implement them if I want in my shop. For now, I'll start with printing. If more customers come for scanning, I will install scanning machine. If more people are coming for fax also, I'll install it. Nowadays, nobody is using fax. So the fact that here, don't create God interface. If you create and if you try to implement it, for what you will create interface to achieve the Lickshow substitution. But while creating that interfaces, try to put a simple interface. For print, create one interface, scan for one interface, fax one interface, so that I can easily able to implement only my required functionality. I can easily able to implement my only required functionality. So now I'll create a interface only for print interface.
Maybe we need all the interface, like all the print, scan, fax, input, all the three. Then we need to do it in same interface or different one.
Different interface. That is what segregation it is saying that create multiple interfaces now. Don't put all the functionalities into the same interface. Create a multiple interfaces. For scan method, create one scan interface, print one print interface. For fax, create one fax interface. Now coming to implementation. For now, my client want only print implementation. Just implement it. He don't want afford or he can't afford scan or fax now. Okay, here print interface is having print method. I'll implement that printer class implements print interface. I'm done. I'll implement only print implementation here. For now, that is enough for me. What it is saying, if you put heavy load on this interface, definitely that will be carried to your class also, right? If print is independent, scan is independent, and fax is independent, why you are putting everything into one single interface? So in future, if you want to discard some functionalities, how you can discard it if everything is together? Unnecessary interface modifications, classes modifications are required. If I have this way, multiple interfaces with multiple classes, if I don't want some functionalities, fax, I don't want so far. Fax is nobody is using. So I want to discard it. I can discard it. I can remove all the fax interfaces and its implementations. Or if I don't want them, I don't even create them. Finally, what it is saying is, try to make your interfaces also single responsible. Okay. It should not have print, scan, fax. These all are different functionalities. Why you are making or clumsing all into one? That is not easy maintainable. Correct. That is not easy maintainable, not easy extensible. So try to make them separate. That is what interface segregation is saying. Interface segregation. Interface segregation principle is saying create small interfaces. Create small interfaces. The question is why I need interface? You know answer. Create small interfaces. For what? Substitutional. Lickshow substitution principle saying use interface implementation model. So this principle is supporting Lickshow substitution principle. All together only we will use. And of course, here we are following single responsibility also. Means for each responsibility, we are creating one class. And we are following interface segregation to create interfaces so that we will implement them so that we can achieve inversion of controlling
Lickshow substitution is possible. That is also we achieved. And what next? And how you will apply it in microservices or in monolithic. So interface aggregation is saying make everything small. Okay, clear, right? Any doubts here? It's
No, sir.
simple. Yeah. So now coming to every pattern you can apply across monolithic, okay, microservice or class level. While designing your modules, client specific interfaces or dependency management or refactoring and evaluation. Okay, just explore through the, a description I'll share through the material. Okay, I'll share one Word document, everything you will see there. Okay, so the modular design, while designing your modules, same thing. In your modules, whatever interfaces you create, make them very small. Okay, client specific interfaces. Let's say I have so many interfaces in my implementation, but for client I want to share only few interfaces. Yes, create client specific interfaces so that we can avoid the showing our complete functionality. Some kind of abstraction also you achieve. How, if you imagine your JDBC driver manager dot get connection will give you implementation in the form of interface only, connection interface. But internally, how many interfaces it have, how many implementations it use, that is none of our business. If you ask some people, they will ask you, do you want to connect with databases or do you want to rewrite the complete functionality? Just you will say, I want to connect with databases. They will say, just use it. Don't go inside into it. Okay. So we all are clients for the JDBC functionality. So we are using as it is. We are adjusting everything in the form of connection interface and we are using it. So some client specific interfaces also in such a way we can create to achieve the abstraction. Okay. And dependency management is simple here. Dependency management is simple here. I have clear interface implementations. I don't have any large interfaces or large implementations. So dependencies are very smaller in size. So tomorrow if I want to change my dependencies, easily I can able to change it. Easily I can refactor it. Okay, everything is simple. Same thing you can apply for the microservices also, granular service, which are simple and smaller service we can create. Versioning, contract testing, everything is, simple. Even you can apply testing principle to everywhere. If you are a tester or if you are from testing background, if already there is a functionality, if everybody continuously modifying it, if they change APIs, it will, irritate you in the testing side. If they make it very small and if they don't modify it, it will be easy. Only new functionality you can test it. Okay. So it is simple that if you can follow interface aggregation, right, it is easy to maintain. Okay. Let me go through document interface aggregation principle. Okay, when designing classes or modules, it is important to identify the specific responsibilities or behaviors. Right? So same example. I have a printer, right? I have a printer functionality. There I don't want all the functionalities of printing, fax, or scanning. So if I can put the printer separately, fax separately, and scanning separately, I can implement them. Tomorrow, if I want to modify printing functionality, I need not to disturb fax or scanning. It is easy to modify. Each client or module should be provided with an interface that expose only to the functionality it required. Client specific interface in monolithic, as I said, right? Like connection interface, which is client specific. You will get a lot of implementations, Archil implementation, MySQL implementation, DB2 implementation, but they will give always that in the form of an interface reference. Okay. Lot of things we have, you can read through it. So coming to microservices, granular service interfaces. Each microservices exposes a well-defined interface that defines its capabilities and how other services or clients can interact with it. Via API, we expose our microservice. While exposing it, if you have smaller APIs, it will be easy to clients also to identify what functionalities you have as part of that API, and they can easily integrate with it. Okay. And while providing that microservices client specific, let's say I have multiple clients. I have APIs or RBI API, but they don't want to give much. RBI is integrated with all payment gateways, Phone Pay, Google Pay. There are so many, UPI providers. They don't expose all the functionalities of RBI to these UPIs. Same like banks. Banks also will have, UPI access. Banks also will have RBI access. UPI people also will have access. But will they provide same kind of access to UPI providers? No. For UPIs, they will provide one kind of interfaces. For banks, they will provide another kind of interfaces. So for every specific client, we can create a separate interface also based on his requirement. This is what I'm talking in microservices level. So that it need not to, really need not to worry about whether that client unnecessarily access my other functionalities which are not permitted to him. I need not to worry. Even we do apply this in, database side also, right? We apply this in a database side, what we call it, while implementing CRUD operations in microservices, right? Let me open this microservice document. We call it as in design patterns you get.
Naveen, we can see only one screen like microservices.
Just a minute. I'm sharing the screen. So in microservices architecture, to achieve this, client-specific interfaces only, database pattern, CQRS, okay? Command query pattern we follow, right? CQRS principles we follow. Let me open this in new tab. For querying, right? API composition, CQRS we follow. API composition, CQRS. You can apply this for interface segregation also, okay? While I am providing API for my database operations, don't create API method which will do all CRUD operations. Save, update, delete, select, all this if you expose through one API, okay? That API I may share with clients. Some clients need only read functionality. Some clients maybe need write functionality also. Some clients may be required read functionality. Some clients maybe need write functionalities also. What problem you will see if you provide everything in a single interface or single implementation? Who doesn't have or don't have write functionality also will get the right functionality. That is a bad design, right? So that is what it is saying. Client specific interfaces, even, while creating access, right? Only give limited access. In such a way, provide interface and implementations. Okay. You able to see PPT? Yes.
Yes.
Yes, sir.
Yeah. So versioning and compatibility. Okay. Already maintain clear versioning. Don't delete old versions. Keep the old versions until unless new version is adopted by everyone. And don't modify the capabilities of old version. Okay. So keep them as it is. Contract testing. Okay. So again, coming to the contract testing, what they are saying is when you provide services, don't modify existing services. Don't modify existing services. Contract testing is a technique used to verify that service is other to their published interface. By testing interactions between services based on the contracts, teams can identify and address any inconsistencies or mismatches. Okay, so while providing a interface, contract is very important in microservices. I'm a service provider A and you are a service provider B. We need to come to a conclusion. Okay, I should not create my clients just by believing that you are providing a object, input object in such a way, or in output object in such a way. We both should sit and discuss. Okay, input in which form I wanted to submit to you, or output in what form I am expecting from you. Okay, such a way we need to create contracts between us. How I am relating it to interface. Interface is not only Java interface. Interface is a access or interface you can imagine from a front end point of view. Okay, for anything you can apply this interface aggregation principle. While providing it, try to make it clear, your interface, so that people can able to easily understand what functionalities I have in this API, or as a client or as a provider, you can limit the access also to them. And gateways also will help you here. Gateways also will help you here for hiding all your implementations from the clients. Via gateway you can share your functionalities to them, so that you can hide functionalities or APIs.
Sir, can we have a name of the gateway which we are using?
Any gateway, cloud gateway, APIM, or Azure gateway, right? APIM we can use. There are other gateways, AWS gateway or GCP gateways, or your Spring Boot gateway also. In Spring Boot also we have gateway functionality. Joule API gateway. Okay, so any gateways that we can use. I'll show you in the microservices discussion. Okay. So end of the day, what I want to conclude from the interface aggregation is, try to create small functionalities. Try to create small functionalities, create small interfaces instead of creating a big interfaces. Okay. So that interface implementation only you can provide, so that you can limit the access. Who want to print, give the print access. Who want to scan, give scan access. Who want fax, give fax access. You can apply that to monolithic and microservices also. And a dependency inversion principle. Dependency inversion principle. Dependency inversion suggests that high-level modules should not depend on low-level modules, but both should depend on abstractions. It also states that abstraction should not depend on details. Rather, details should depend on the abstraction. For example, considering high-level modules that needs log data, instead of directly depending on a specific logging library, it should depend on the abstraction interfaces like logger. And logger interface is having so many implementations, right? Database logging, file logging, and coming to implementation, we have SLFJ logging implementation. We have what we say, log stretch implementation we see, right? There are so many implementations for logger API. So dependency inversion. Dependency inversion is saying same dependency injection. Via dependency injection, we can get this dependency inversion. How? Let's say today I have functionality, same example, right? For Elixir substitutional, whatever I have shown. Okay, if I show this, paint, how you can understand it is, dependency inversion principle. Dependency inversion principle. I'm giving just example of databases. Okay, I have a business class or a service class here. A service class I have here, customer service. This customer service is having functionality of okay, customer database, customer DB service, customer DB or DAO, which is using internally JDBC. JDBC and connecting with one database. So now if I directly include customer DAO interface here, okay, if I use customer, customer DAO object directly, if I create here customer DAO directly, if I use here, it will become tightly coupled. It will become tightly coupled. So it's a bad way of creating a reference here. Instead of that, if you follow Likshow substitutional principle, right, what you can do first, you can have a customer interface, customer DAO interface here. Into that customer DAO interface, you can inject it. You can have customer DAO interface here, and you can pass this implementation here. You can pass this implementation. Okay, interface Likshow substitution principle is saying use interfaces and provide implementation objects. One corner it is saying use interfaces and provide implementation object, but who is providing? Which principle is providing this implementation to interface? That is what dependency injection principle. Via dependency injection, who is providing support here? Factories. Factory providing support. What is factory? Your inversion of IOC containers are providing support there. Your factories are providing support there. So via factories, you can create implementation objects. Factories will do what? They will help you a lot. When you use IOC, IOC will create this customer DAO object. It will create object on your behalf. That object it will inject into this interface, so that you can achieve dependency inversion. What is dependency inversion? In future, if you don't want this customer DAO implementation, which is in JDBC, I want Hibernate implementation. You can create customer Hibernate DAO. Hibernate DAO implementation I can have from the same interface. Now I can ask my factory, use this object instead of old object. I'll disconnect old object in my factory. This object also same way it will inject into this interface without any worries. So IOC containers will make it possible achieving dependency inversion, right? Easily you can achieve by using IOC. Spring IOC is one of the example for it. If you know Spring IOC module, almost you understand all the features of Solid, right? By following MVC, we create all the classes, we follow single responsibility, we create interface implementations, we substitute the functionalities, we create small interfaces. Via dependency injection, we achieve dependency inversion also, right? If you know Spring IOC module, if you know Spring IOC module means, Spring IOC module, which means you understand all this. In Spring IOC, we discuss MVC, which says how to follow single responsibility principle, right? And there we discuss about dependency injection. In dependency injection, you will understand dependency inversion principle. You will understand Likshow substitution principle, interface aggregation principle, and what all on you need to follow is one principle is open and close. Okay, practically you need to follow this open and close. This is a big principle, actually more important also. Okay, open and close, which helps you a lot in sharing your APIs to the customers, maintaining the versions. That all you will understand from this open and close. Okay, in real time, that is important. Which means MVC is not important? No, it is important, but already you people know about it. Single responsibility. but you don't know whether we should call it as single responsible or not. Yes, you can call it single responsibility principle. And other dependency inversion, lick-show substitution, interface aggregation, all are same. All are finally achieving dependency injection. Via dependency injection, we are achieving it via dependency injection. So finally, if I make my application by following all these principles, it is easy to maintain. Finally, what I am achieving it easy to maintain. If I build a car, my car should be easily maintainable. If tomorrow something damaged, I should be able to easily replace it. Same way your application also. Same way your application also. If one small part damaged, that small part I should be able to replace easily. Okay. So if you follow the solid principles, you can achieve the same thing in your applications also. Single responsibility, open close, lick-show substitution, interface segregation, and dependency inversion. Is it simple or not? Already you are aware of it, but you don't know. We call it as solid. Okay. By end of the sessions, right? If you are part of my Spring sessions, by end of the Spring Boot and microservice sessions, you will realize that you are following all solid principles. You are following all solid principles, and you need to follow them to make your application more robust, easy to maintain, easy to readable, and the clients also, right? Sometimes it will provide security from the other clients, and sometimes it will give flexibility to the clients. Okay, lot of things we are achieving it via solid. It is important to follow. Okay, I'll share the document and the PPTs with you. Okay, just I'll ping you in the group, in our WhatsApp group and Telegram groups. Okay.
Hello, sir.
Yeah.
Are you going to discuss the design